Okay, hi guys, Miss Mad again. Today we are doing electricity, the grade 12 work. So by the end of this lesson, you should be able to calculate internal resistance and EMF and be able to describe and explain EMF, terminal velocity, as well as internal resistance. So before I do that, I actually just want to explain what it all is. Just give me a second to change my screen. Okay, so imagine you have a circuit. Oops. Okay, and the circuit has one lamp, and then around the circuit for our battery, okay, it tells you that the battery has a voltage of, let's say, 1.5. Okay, and then you go and you take a voltmeter. Oops. Okay, and on that voltmeter, it tells you that your battery only has a value of 1.2. Okay, so there's obviously a clear difference between what the battery tells you it has. Sorry, I don't know what's happening with my whiteboard today. And what the voltmeter tells you the battery is giving you in terms of potential difference. Okay, so what we refer to as this value over here, the 1.5, is your EMF. Okay, it's your electromotive force. And that is always a constant amount. So this amount can't change. The reason being, this is dependent on your battery and the chemical reaction happening inside of the battery. So this is due to the chemical reaction in the battery. So they are telling you that if you buy this battery, it has the potential to have 1.5 volts that it gives off, okay? But like I said, when we measured it, it only gave 1.2. So this we call the terminal velocity. And the other way that we can call it is called the V load. Okay. And the reason we call it the V load is because this little lamp that we have here, we actually call that fancy name as a load. And that is just a fancy way of saying it is an external resistance in the circuit. Oops. Okay, so basically this thing is just using up the current to transfer your electrical energy into something else, whether it's heat or light or whatever you want to call it. Okay. So if you now look at this battery, this terminal velocity is then the potential difference of the circuit. So it's your voltage of the circuit. And if you want a formula for it, V load is equal to I R, and that is your overall resistance. Okay, now the one big thing that you should have noticed is that we are still, let me just get another color. Okay, we are still having a difference in the potential difference over here, okay? And that difference is called internal resistance. And if we show it as something, we say it is your V lost. So it's the potential difference that you have lost in your system, okay? But now a very important thing, what this tells us is that your battery actually has, has resistance. So if you were to draw the battery, the way we actually draw it could be like this. So that whole thing is seen as your battery now. And this whole thing is supposed to give you 1.5 volts, which it doesn't. So what we then can say is, think about it as the 1.5 volts comes from the fact that if you just had the battery and you didn't have any resistance in your battery, it would have been able to give you 1.5 volts. But the only time that this is possible in a battery is if there is zero current in it. Because as you put a current through this battery, your electrons and your protons need to move around in this chemical reaction, and that uses up energy. And when it uses up energy, that is the little bit that we refer to as your V loss, your internal resistance. So in this case, your V loss is equal to that EMF amount minus the V load. EMF minus V load, which is equal to 1.5 minus 1.2, and that gives you an amount of 0.3 volts. So what we are saying is that this battery basically uses 0.3 volts to let this chemical reaction take place and let the electrons run from the one side of the battery to the other side of the battery. Does that make sense to everyone? Yes. Okay. Have you all copied it down? Can I erase it and draw the next thing? If you were copying it down. Okay. So I'm just going to erase this bit. Let me keep my drawing. Okay, so if we now have to find a formula, we can actually say that we can have this formula. Okay, so your EMF is equal to the current times the overall resistance, which is basically your V load. Plus your current times your smaller resistance, your internal resistance. So this little thing inside of your battery, we give a small r, and that refers to your internal resistance. So that's your V lost. Represents your EMF. Okay, so that's what I was giving you with this formula over here when I was working out the difference. But what we can also do with this formula is we can factorize it a bit, and we get that EMF is equal to I times R plus small r. So it's your overall resistance, sorry, it's your current times your overall resistance plus your internal. And a way that we can now represent this formula is on a graph. Okay, so imagine that we measure your V load at different currents. So this is current measured in amperes. Okay, and we get dot there and a dot there. Okay, those are our data points. So we draw a line through it. Okay, you can now extrapolate this line to a point over here on your y-axis. Okay, and that point is your EMF. That's this. So that point is your EMF. What do you notice? It's the line. It's the dot on the y-axis. So it means it's at 0. So what this graph is trying to tell you is we can only measure EMF when your current is 0, exactly like I was saying here. So you can only ever get the true value of EMF when your current is 0. So you can't technically measure it, because otherwise, how are you going to measure voltage if you don't have a current? So this is always an extrapolation point. So technically speaking, on your batteries, they're giving you a tentative idea of what should be your value based on extrapolation, but we can't really ever physically measure it. Does that make sense to everyone? So if we now were to write the formula, we could actually rearrange this formula and say V load, and I'm doing this so that I can actually show you what the gradient of our line is equal to your EMF minus your internal resistance bit. And then we all know from this graph now, this value is equal to that value, which is on your y-axis. So if you now think about the normal y equal mx plus c equation, this is our c value. This is our y value, the value we are trying to get. Okay. This over here, my x value, because that is your x-axis. So over here. And then this, the small r, and it's negative. Okay, it's actually your slope. So in this case, your slope, Cal, I'm going to read your question just now, is equal to negative r. So a graph like this could actually tell us what the internal resistance of your system is. How would we calculate the EMF? So you would have to go and work out. No, they can't give you 2 unknowns for a question. So they can't ask you to calculate EMF if they haven't given you internal resistance, or a way to work out internal resistance, which you can then later substitute into one of these. They'll never give you two unknowns in an equation. Okay, so that was just explaining it to you guys. I'll quickly go back to the slides. Okay, so like I was saying, just basics. If you wanted to see the image again, your big R in your system is always your external load resistor. The small r is always your internal resistance. The V is your terminal potential difference. So like I was saying, your V load, your epsilon, sorry, that weird E thing in the Greek term symbol is EMF. And then your load is an external resistor in the circuit, so like a lamp or some kind of resistor or something that makes heat. Yes, Zakanya, the slope is equal to minus R because you have a descending slope, so it has to be negative. And the R comes from the fact that if you have the formula, that's the only thing left that could be the R, the slope. Okay, and then like I said, EMF just stands for electromotive force, and it's always constant, it won't change because it's based on the chemical reaction inside of your formula, inside of your battery, sorry. Okay, so then just again, those formulas, your V load is equal to the current of the system times, yes, the R always has to be negative. As your current increases, your internal resistance should decrease because more electrons are flowing inside of the battery moving to the other side. So just go look at your relationship between current and resistance. Okay, and then the potential difference of the battery is related to the EMF in that formula that I was showing you. So we're all formulas, we understand all of them, easy peasy. Okay, then explain what I was just explaining to you in that line graph. So you start off in this graph at, I hope you can see my mouse. So you start off at 0, and that is the point where your EMF would be the greatest. And then it's going to decrease always. So as current starts going through the system, it'll decrease. The difference between your V load, which is your terminal velocity, your terminal potential difference, and your EMF is always going to be equal to your I times R, or your V loss. And that's all that this little graph is showing you. It's just showing you where you could get what. I've never seen this in I've seen this in textbooks, but I've never seen this in a question paper. So if you don't get this graph, I wouldn't worry too much about it. Okay, so the best way to practice this, well, to understand this is to practice this. So this is the November 2018 paper. Let me just get mine. Okay. Okay, so it's question 8 in paper 1, and they tell you the battery in the circuit diagram below has an EMF of 12 volts and an internal resistance of 0.5 ohms. Resistor R has an unknown resistance. Then they ask you 8.1, what is the meaning of the following statement? They say the EMF of the battery is 12 volts. So all you have to write here is that the potential difference oh, I'm sorry, let me just share my screen. I don't know why I did that. Do you see the right question now? Nog steeds niet. Hold on. Don't know why it's doing that. Ugh. Okay, those my questions show now. Sorry about that. I don't know why that happened. Okay, so sorry. So they give you this circuit and they tell you that your EMF is 12 volts, they tell you that internal resistance is 0.5 ohms, and they tell you that you don't know what the R is in your last little circuit, and then they're asking you what is the meaning of the following statement. So they tell you the EMF of the battery is 12 volts, okay? So what you have to say is that the potential difference of the battery in an open circuit is 12 volts, okay? And you have to mention the open circuit because remember I was telling you the only time you will get this is when there is zero current going through your circuit. So if you don't say the open bit, you won't get the marks. Another way that you can say it is if you're referring to the energy. So you can say the maximum energy supplied by the battery per unit charge is 12 joules. Okay. Normally for these type of open-ended questions, they'll give you about 8 options in what you can choose, as long as it shows that you've got understanding of the concept. So you are aware of the fact that as soon as a current is connected to the battery, you can never ever get to 12 volts because of the internal resistance. Okay. Then they say the reading on the ammeter is 2 amps when switch S is open. Okay, so that means it is not going through your 2 ohms resistor, it is only going through your R. And then they say 8.2, calculate the reading on the voltmeter and the resistance of resistor R. Okay, so I'm just going to copy the image and then I'll go to the whiteboard again. Just give me a second so I can show you guys. Yes. Just going to keep the image there so that we can see it. Okay, so they were asking us for the reading on the voltmeter. So we basically want to know what V lost is. And that is equal to, I mean, we want to know what V load is, but in order for us to know what V load is, we have to find V lost first. Okay, so 8.2.1, they're asking for V load. Okay, so they're asking for your reading off of this voltmeter. So V lost is equal to I times R. And in this case, they gave us the current as 2 amps. And we know from in the question as well that our internal resistance is 0.5 ohms. So our V loss would be 1 volt. And then we can use the formula V load is equal to EMF minus V loss, which is equal to 12 minus 1. So our answer is 11 volts. That's our final answer. Okay, you could have just used this formula as well. EMF is equal to current times overall resistance plus internal resistance. It's probably better to use this formula if you are comfortable with it and you know where all the values come from. I would just multiply it out. So 12 is equal to V load plus 2 times 0.5. So in case you were worried, so it's 12 equals V load plus 1. So in case you were worried that you would have made a mistake using two formulas, then just stick to using the one. I prefer doing it this step, but that's your choice. They mark both formulas. I think there's actually a third and a fourth one that you could use, and they'll mark it. So just make sure that you use one of the formulas on the formula sheet, whichever one you're comfortable with. Okay, and then the second question, they were asking us for the value of resistor R. So 8.2.2. You want to know what R is. Okay, that one's quite easy. We're just going to use our normal ohm relationship. So our internal, or our V load now comes from our answer here. So it's 11 volts divided by the 2, which they gave us in the question. And we should get 5.5 ohms. Okay, then let's go see what the rest of the question says. Everyone's fine with that? That makes sense what I just did? So then the next question, they tell you the switch S is now closed. How does the change affect the reading on the voltmeter? Choose from increase, decrease, or remain the same. Explain your answer. Okay, so they're basically checking whether you are understanding that you are now working in a parallel circuit, sorry. So what happens when you add more resistance in a parallel circuit? Any ideas? No, resistance actually decreases overall. Yes, Jonathan, you're right. So when you add, so I'm just going to erase this. When you add more resistors in a parallel circuit, you are actually decreasing the overall resistance. Remember, for a parallel circuit, it's 1 over. So the more you add, the bigger the denominator becomes, and that means that your overall thing will become smaller. Okay. Then just on a side note, the other way that you could have argued out that question is if you use this formula, okay, we know that this EMF value always stays constant. Okay, that can't change. This value over here is going to increase because a parallel circuit is a current divider. Okay, so this overall thing will increase. So that means for this to stay constant, if your internal resistance or your V lost increases, then your V load automatically has to decrease. Okay, so think about it as a weighing scale, balancing scale. Your E is resting right there in the middle, your epsilon, your EMF. This is your V lost. And this is your V load. Okay, so if this value increases, it's going to go down and your system will go skew. But it can't go skew because this has to stay constant, this has to stay balanced. So the system will have to increase to undo that decrease. Okay, but biggest thing here is you're working with a parallel system. When you are increasing the overall resistance, when you are increasing the number of parallel circuits and the resistance in them, you are decreasing your overall resistance, which is a good thing for your V load because that's equal to IR, and that amount will decrease. So it will automatically decrease. Okay, let's see what the next question asks. Okay. So then the next question, question 9, they tell you perform an experiment to determine the EMF and the internal resistance of a battery using the circuit below. So they show you the circuit, and then they tell you the learners use their recorded readings of current and resistance together with the equation R is equal to EMF over I minus R. So that's the formula. And to obtain the following graph, and they draw the graph. And then they ask you which variable has to be kept constant in their experiment. So in this question, they're kind of just checking whether you remember what you learned in grade 11. And they're trying to see whether you still understand that in order for all of these calculations to work out, we have to understand that we're working with Ohm's law. And the only way that Ohm's law works is if temperature stays constant. So your temperature has to be kept constant. Does that make sense to everyone? So the only thing that you can keep constant here is temperature, because you are changing the current, and that is going to be your small r, and you're looking for resistance. Okay, then the next question says, write down the value of the internal resistance of the cell. So I'm just going to grab this into whiteboard again. It's just easier to explain. Just give me a second. Okay, so what they are asking, whoops. So they're basically asking you if we are working with the formula, because they were R was equal to epsilon over I minus R. Okay. They are asking you what is R, small one. Okay. So the first thing you have to do is identify on the graph what is going to represent your R. So this is your, always think in terms of the formula of a straight line. Okay, so that is your Y value. Your EMF is your X value. This is your slope. So your M is equal to, no, I'm wrong. Sorry. This is your X value. My bad. Okay, if you look at the, yeah, this is your X value, 1 over current. So 1 over current is going to be my X. So 1 over I. And that means that this is my slope. So that's my M. And that means that this over here is my C value. Okay, so we have to go look, where does this thing cut your x-axis? So if you look at it, every two blocks is a number. So 1, 2, 3. So it's going to be -3. Okay, and because you have a negative in front of your value there, R is going to be equal to 3 over. Wow. Does that make sense to everyone? How we got to that value? And everyone's silent. Okay, then question 9.2.2, they tell you calculate the EMF of the battery. Okay, so the EMF is your slope, so you can basically use any values. I am going to use this value, and I am going to use this value over here just because they are on lines. For me, it just makes it easier. So EMF is equal to the change in R over the change over current. So that's going to be equal to, that's halfway, so that should be 7.5. Okay, so it's going to be 7.5 minus -3 divided by, so 1.5 minus 0 is equal to, put it in your calculator and you should get 7 volts. Correct me if I'm wrong. Okay, so that is how we work out your EMF, because we've identified that it's our slope. How do we work out slope? You take 2 points. So M is equal to delta Y over delta X. Okay, does that make sense to everyone? Yes, no, maybe. Okay. Let me go back to the question. Oh, okay, so that's the end of that question paper. Let me just open the other one that was open earlier. Just give me 5 seconds. Can I explain 9.2.2 again, please? Yes. Let me do my whiteboard. Okay, so they ask you to calculate your EMF, okay? And from the formula that they gave us, we identified that EMF is equal to your slope. How do you work out slope on a straight line? You have to take your change in Y over your change in X. So I chose this point over here, which is 0, -3. And I chose this point over here just because it's online. It's just easier for me to see, which was 1.5 and 7.5. So this was my point 2. This was my point 1. So then to get your EMF, you just say 0.2y minus 0.1y divided by 0.2x minus 0.1x. And that is how we got to 7.5 minus -3 over 1.5. Okay, someone was just asking me to re-explain that. So does that now make sense to everyone? Everyone knows where it comes from? Okay. Okay, so then looking at, everyone seeing the November 2017 paper? Yes? Okay, cool. So question 9 tells you, learners investigated the relationship between potential difference in current for the combination of 2 resistors and R2 in one experiment. Resistors R1 and R2 were connected in parallel. In a second experiment, they were connected in series. The learners then plotted graph X and the results of one of the experiments and Y the results of the other experiment. So then they give us this graph, and the first question they ask us is to state Ohm's law in words. So you just need to say that the potential difference or voltage across a conductor is directly proportional to the current in the conductor at constant temperature. And probably the most important part of that sentence is the constant temperature bit. Okay. Then question 9.1.2, they ask you, what is the physical quantity, what physical quantity does the gradient, the slope of the VI graph represent? So if we look at this, they're asking you, yeah, but they're asking you to, yes. Okay, so Jonathan is correct. It is your resistance. Whoops. So always remember that V divided by Ri is equal to R. And in this case, your difference is your Y, your current is your A. So slope M is equal to change in Y over change in X. So it's change in potential difference over current. Does that make sense to everyone? Okay. Then they're asking us to calculate the gradient of slope X. I'm just going to do this on a whiteboard again. Oops. Okay. So we have to calculate the slope. So we have to choose 2 points again. So I'm going to choose this point and this point, but you can choose any other points. So that is 0,5 by 2, and that is 0,25 by 1. And so M, or gradient, let's just rather write that. Ooh. I promise my handwriting is better than that, by the way. It's delta V over delta I, which is equal to 2 minus 1 divided by 0,5 minus 0,25. And that is equal to, if you put it into your calculator, 1 over 2,5, 0,25, sorry, which is equal to 4 ohms. Okay, so does it make sense to everyone how we work out the gradient on these graphs? Just find points, lines to indicate what they should be. It would be risky choosing like a point here or there just because you're making a guess. Okay, I see we're almost out of time. So tomorrow we will just finish up this paper and do the 2016 paper as well as the 2015 paper. And then that is everything for electricity grade 12. And you have basically covered the topic. You all should be fine of electricity tomorrow. So which topic would you guys like me to move on to from Monday onwards? Any ideas? If you don't have ideas right now, think about it so that you can tell me tomorrow. Electrodynamics. Okay, so we've got two choices, electrodynamics or the Doppler effect. Okay, it looks like Doppler is winning. So let's do Doppler first, and then after the Doppler effect, we'll move on to electrodynamics. Does that seem fair to everyone? So then Monday we'll start with electrodynamics, Doppler effect, and then tomorrow we'll do more of these past papers. And yeah, okay. So enjoy your day, guys. See you tomorrow, same time.